Good morning, class. Today, as you are aware, I'm not available to be with you in class. I'll be attending a conference in Polokwane. It is on the use of technology in higher education. So I've decided to start using the technology as I share with you my today's class, which is on wetlands. I hope you are going to enjoy this. Any questions, any queries, as usual, try to take note of them and post them on our group WhatsApp chat. I'll try to be available during the class time, or you can just post. If I'm not available, I'll attend to your queries before you attempt the task, which is at the end of the presentation, which is all groups are expected to participate in the task. So let's go and see what this chapter or this discussion today is about. Wetlands are biologically diverse and productive ecosystems, and these are home for a variety of plant life. These include the floating pond lilies, the cattails, the cypress, the tamarack, and blue spruce, and many others. Wetlands support diverse communities of invertebrates, which in turn support a wide variety of birds and other vertebrates. Primary consumers in wetlands, these are like the crustaceans, the mollusks, the aquatic insects, the larvae, or the macros, the geese and the deer rely on the abundance of algae plants and detritus for food. These primary consumers are like our herbivores that feed on plant life. They are plant eaters. Wetlands also support a variety of carnivore species. The carnivores are the meat eaters, which includes the dragonflies, the otters, the alligators, and the osprey, and there are so many others. This picture here is showing a wetlands, what happens basically in a wetland, how it looks like, where we have got plants, we have birds, we have butterflies, you name it. So there's water, vegetation, and animal life in wetlands. Wetlands have three basic definitions which have been accepted. One of them is by the US Fish and Wildlife Service, which states that these are lands transitional between terrestrial and aquatic systems where the water table is usually at or near the surface, or the land is covered by shallow water. Terrestrial ecosystems are from the terrain, and aquatic are those ones that are covered by the water, wet ecosystems. There are three basic attributes here. At least there's periodically the land supports predominantly hydrophytes, and these hydrophytes are the plants that love water or that adapt to water, or plants that can grow in water, hydrophytic plants. The substrata is predominantly undried hydric soils, the soils which are always wet. They are saturated in water, or seasonally saturated in water, or periodically saturated in water. And the substrata is non-soil and is saturated with water or covered by shallow water at some time during the growing season of each year. The second definition is the one that is provided by Ramsar, the Ramsar Convention on Wetlands. I've given you the website so that you can go and have a look at what the organization does, when it was formed, how many sites have been conserved or are being protected, and many more. This Ramsar Convention states that wetlands are areas of marsh, fen, peatland, or water, whether natural or brackish, permanent or temporary, with water that is static or flowing, fresh, brackish, or salt, including areas of marine water, the depth of which at low tide does not exceed 6 meters. Ramsar Convention. Ramsar is a city in Iran where the convention took place in 1971. The convention was signed in 1971, and what it entails is it looks at, or the convention tells that it is rather an intergovernmental treaty that provides the framework for national action and international cooperation for the conservation and wise use of wetlands and their resources. We have about 2,354 sites that have been identified by Ramsar and are protected by Ramsar Convention. And in South Africa, we also have sites that have been identified by Ramsar and they are protected by Ramsar. These sites, will visit one of them in the third definition is the one provided by the National Research Council. The council it looks at wetlands as essential characteristics of a wetland are as recurrent, sustained inundation or saturation or near the surface of the presence of physical, chemical, and biological features reflective of recurrent, sustained inundation or saturation. This is more scientific with more big terms, but what I would like about this definition at the end of the day is also looking at talking of the hydric soils that are always wet, and then the hydrophytic vegetation that can grow in water. So if you are asked to write the definition of wetlands, you can look at these three, come up with one that can, as long as it is explaining the hydrophytic plants, as long as it is talking about the hydric soils, and as long as it is also including the issues of water. So in other words, those are the common features of a wetland: the hydrology that results in wet or flooded soils, soils that are dominated by anaerobic processes, and the biota, particularly rooted vascular plants that are adapted to life in flooded anaerobic environments. I would like at this moment to ask you to recall or go and look at what are anaerobic processes. Do you still remember them from our previous classes? If not, please go back, take note. In the next class we are going to meet, I would like you to explain to me what these anaerobic processes are. The abiotic factors that influence our wetland ecosystems are the water, how it moves or how it is distributed, and the quality of it as the primary factor influencing wetland structure and function. The presence of water in a wetland contributes to the formation of hydric soils, which are formed under flooded or saturated conditions, persisting over a very long time or enough for the development of anaerobic conditions. Water conditions in wetlands varies with respect to the timing and the duration of the surface water inundation, as well as the seasonal. In coastal wetlands, tidal is the main factor that influences or drives the movement in the distribution of water, whereas in inland wetlands, where we lack the daily tidal influence, this can be permanently flooded on one extreme or intermittently flooded on the other extreme. So these inland wetlands are the ones we find in Limpopo, because we are landlocked, we don't access the seas. What we have our own inland wetlands. And what now happens is the water in a wetland has water that enters it, while some of it stays in the wetland, some of it leaves also the wetland. This can be for portrayed in the following figure, which is sizing a wetlands and how it budgets the water. So we call it a hypothetical wetland water budget. For instance, we have precipitation, net precipitation, we have surface water, and we have groundwater entering a wetland, and also tides bringing in wetland water into the wetland. And then we have the evapotranspiration processes taking place. Water leaves the wetland. It leaves also through surface flow, and it also leaves through ground flow, and also the tides takes water as they leave back and forth from the wetland. In wetlands, flooding affects the physical chemistry of wetlands in various ways. Water can introduce or remove sediments, salts, and nutrients, or other materials from wetlands, thereby influencing its soil and water chemistry. This influences the structure and function of wetland ecosystems or species richness, productivity rates, and organic matter accumulation and nutrient cycling. This may also restrict species richness in areas subject to long-term flooding, while enhancing it in areas with variable or pulsing hydro periods. The anaerobic conditions created under flooded conditions limit decomposition rates, hence promoting organic matter accumulation in soils, and can alter reduction oxidation reactions, controlling nutrient transformation in wetland soils. The saturation of the wetland soils by water leads to the formation of anaerobic conditions as oxygen is depleted faster than it can be replaced by diffusion. Remember to go and look at what these anaerobic conditions are. The rate of oxygen loss in flooded soils vary depending on other soil conditions, which are like temperature, rates of microbial respiration, and in most wetlands, small oxidized layers of soil may persist on the surface or around the roots of vascular plants, but generally anaerobic or reduced conditions prevail. The prevalence of anaerobic conditions in wetlands has impact on their biogeochemistry, with important implications for carbon, nitrogen, phosphorus, iron, manganese, and sulfur transformations. Wetlands can function as sources, sinks, or transformers of these materials, depending on inflows, outflows, and internal cycling rates. Like, for instance, we can have the nitrogen cycles, we have the oxygen cycles in wetlands. One such anaerobic transformation is the process of denitrification, in which nitrate is lost to the atmosphere via conversion to nitrogen gas or nitrous oxide by bacteria. You can ask why wetlands are considered maybe very important as they sink carbon. Today, with the issues of global climate change, we say let's protect the wetlands as they act as carbon sinks. We don't like too much of the carbon in the atmosphere. It's the one which is giving us problems of this warm blanket. Hence, if wetlands can sink and store this carbon, it means they are very critical to us. In many wetlands, nutrients availability is dramatically altered by agriculture or other practices that increase nutrient loading, contributing to changes in ecosystem structure and function. These are mostly due to human activities in wetlands, activities such as use of pesticides and fertilizers as we grow crops in nutrients, or as we deposit raw materials, sewage disposal in wetlands. It increases the nutrient loading and contributing to changes of the natural wetland ecosystem. Through processes like denitrification and plant uptake, wetlands can help remove some of these excess nutrients like nitrogen introduced to wetland and systems. Predominance of water and anaerobic conditions make organisms like rooted plants to exhibit remarkable adaptations to deal with the stress imposed by flooding. These adaptations include the pressurized gas flow, creation of oxidized root zones, and anaerobic respiration allow wetland plants to remain productive under otherwise stressful conditions, making wetlands among the most productive ecosystems in the world. Remember, I would like you to look at what anaerobic respiration is, revise from our previous work, discuss with your friend or colleague, revise your notes and check and tell us in the next class what these anaerobic respiration processes are. This high primary production in turn support high rates of secondary production, rates that can exceed those of terrestrial ecosystems. So they are very productive, high rates in wetland areas that exceed those of our terrain ecosystems. Plants in wetland ecosystems use what we can call a pressurized gas flow. What happens with pressurized gas flow is it's a mechanism for overcoming oxygen root deficiency in plants growing in these anaerobic wetland soils which are always wet, soils which are always flooded in water. So the gaseous transport results in the flow of oxygen from the atmosphere to the root, and then carbon dioxide and methane leaves the roots to the atmosphere. From this figure, this lily, floating leaf, the lily is showing that the brown color is with the arrows pointing down, oxygen entering the plants, and then it leaves as carbon dioxide and methane gas. This you can find it from Nature Education. Wetland plant develop in response to environmental gradient. This is based primarily on their individual abilities to tolerate to flooding and anaerobic soils, but also in response to biotic interaction with other species. What do we mean? This figure here shows how the wetland gradient is. You can see the salt marsh plant communities shift in dominance from the permanent zone where there is always water, and then the first to the second along an elevation gradient, there's transition into marine pine uplands, and up there in the temporary zone we've got the pine lands, and then in the seasonal zone you find the juncus bromelias growing. So it depends with how these plants are able to adapt to these stressful conditions. This picture, I took it as I was driving past Kruger National Park. It also shows that the wetland at the center there, where it is always waterlogged, flooded with water, and then the next zone, which is the seasonal zone, where we have more of the grass species growing, and then we have the permanent or the temporary zone where there are tree species. You see them. So that's how wetlands plants try to grow and adapt to the anaerobic. The development of these productive and diverse plant communities fuels what we call very complex food webs. We know from our previous classes what a food chain is. A food chain, for example, you can have vegetation down as grass, and then we have a grasshopper feeding on the grass, and then we have maybe a bird species feeding on the bed, and the circle goes on like that. So with wetlands, the food webs, it's an interconnectedness of these activities in an ecosystem is so complicated. But not only not only sustain the microbial communities through large inputs of detritus to wetland soils, but also support diverse communities of animals that utilize wetlands for part or all of their lives. Detritivores such as the shredding insects and crayfish can utilize dead plant materials as their primary source of energy, whilst others, for example, the marsh, the periwinkle snails, help process organic matter for subsequent use by other organisms. This picture here is showing the food web of a wetland ecosystem. It's a simplified one where few organisms have been just picked. You see the carnivore feeding on the wetland snakes. We see the birds feeding on the fish. We see the duck feed, all kinds of activities happening, energy being transferred from one organism to the other. Herbivory of algae by invertebrates and small fish and of plant biomass by some invertebrates, birds and mammals. For example, the grasshoppers is the energy source for primary consumers. You know, is primary consumers is those that eat plants, those the herbivores, they feed on plants. Hence, we call them primary consumers. And then the secondary production by these primary consumers supports higher trophic levels, including the predatory insects. The predators are the meat eaters, which we also call the carnivores, or even the animals like our cow, which feeds on grains. Again, it's a predator. Once you're feeding on another organism, you are or it is a predator. Insects, fish, reptiles, amphibians, and birds and mammals. This material is obtained from Cherry and Jay in 2011, Ecology of Wetlands Ecosystems. I find it to be very useful, very helpful if for one who wants to understand in simpler terms the ecology of wetland systems. There are many other journals online that you can also visit and have a look. Don't also forget to visit our prescribed text, which is in our course outline, and you can also visit the websites I have provided here, which are these two websites consist of information on what wetlands are. They've been recorded. They are very nice videos. I would advise you to watch to each video. Each can just take 5 minutes or less, or even if it's longer, you can continue later on and see how wetlands are described, what they are, and what they do to us and what they support us. You can do this either in your groups or individually. You can choose what you want, but I really advise you to listen to these videos. Now we go on to the activity that I would like you to do in your groups. This group task is due on the 22nd of July 2019 at 0800 hours during our class time. What I would like you to do is in your groups prepare a 10-minute class presentation on the following: groups 1, 2, and 5. You have to giving examples. I would like you to identify wetland types that are found in South Africa. And groups 3 and 4, you look at the importance or values of wetlands. If you have any questions regarding these tasks, you are still free to share with me in our WhatsApp group so that we clarify issues. And on the 22nd, we have interesting presentations in class. I would like you to work as a team, work as a group, sit down and come up with interesting presentations. I know wetlands is a very interesting topic. Enjoy it and have a good day. The good thing I told you before, that you can pause on these slides, you can replay, you can take down some notes and do so many activities. Thank you. Goodbye, class.